everybody, this is Coding Cleverly. Today's video is about recursion, and this is going to be an extension to the previous video. So I just wanted to give a little more insight on how we can perform recursion. And to this video, we're going to have a basic example, and it's a really famous factorial function. So we're going to create factorial functions, and we're going to change them up with using for loops, and we're going to use while loops, and also we're going to use recursions, and we're going to differentiate with all of them. So in the last video, we had countdown and we created recursions and we understood the concept of this. For this code, I'm going to be having it linked up on my GitHub repo. So I'm going to be having that link in the description so you could check the code and alter it if you would like. So now we're going to have this factorial function. So I'm going to be creating over here in my new file. So I would encourage you to type along with me. So hash include IOStream, and then we have using namespace standard, we have integer main, and we also have the return 0 semicolon. We're gonna have a function over here, so it's gonna be called, it has a return type of int. It's gonna be called factorial, all right? So it's gonna be fact using for loop. So how do we perform factorial? For those of you who aren't aware, factorial is like a process that would happen. Like if I say for factorial, that would mean it's represented like that. So it would mean like 4 multiplied by 3 multiplied by 2 and multiplied by 1. So it's just going to keep on going down, and you'd see the answer for this is 24. So this is 24. So this is how factorial works. So let's implement it using that for loop. So let's have a for loop inside of it. So I have a for loop that goes from basically it would go from 1, and what's going to be, it's going to say the condition is I is less than equal to num, and then would say I++, which is the incrementation to this. And inside the body, what I'm going to do is basically having a factorial. So basically I'm going to create a variable which is tot for total. It's going to have the number which is 1, and it's going to be multiplying it with the changing number, the iteratable, I would say, variable. And now it's going to keep on changing until the tot changes, and once we're done with the loop, we're going to return what we got. So this tot will have our answer of factorial. So to prove this correct, we'd have a function test over here. So I'm just going to print out the factorial of, let's say, 5. Now it's supposed to give me 120 as my answer, but before that, let me have a console output, since this function is returning an int. So I'm going to copy this, and first of all I'm going to run the code. Now you can see my code is compiled, and now it would say that tot is equal to 1. Tot was not declared in this scope. So line number 6 has an error. Line number 6 says it's not declared. So we're gonna just put an int over here, and hopefully now it would work. So run code. And yes, 120 is the answer. This is correct. So this is how our for loop factorial function works. Now let's come on with while loops. So how do we implement using a while? So I'm saying return type, I would say factorial, I would say using, I would say while. And now inside of it, I would put number. And now what I would do is basically have the integer tot right here. And the tricky part here is that I'm gonna have to create my iteratable variable. So the iterating variable will be I is equal to 1. So I'm gonna have a condition that says I is less than equal to number, and it's just gonna keep on going and putting this stuff inside. So what is it? Tot is equal to tot multiplied by I. Now note over here, you could write it like this as well, not equal to 1. This is much more clear. This is just explicitly explaining it. Yeah, so this is just a shortcut. It still works the same. So it's just multiplying, and actually not 1 but I we're gonna have over here. So tot multiplied, same thing as what I would say, tot is equal to tot multiplied by I. Same thing like that, and that's what we have to do. And now we're gonna have to explicitly tell that we have to plus it. So this is the code for it. Now what we're gonna do is basically have it returned over here at the end. So return tot. Now by default standards, well, what we could talk about factorials is that calculating a factorial of 0 will give you 1. Now this is just defined. So to add that, I would just have it over here inside. So I would say if number is equal to 0, I would just say return a 1. So I would say return a 1. And the same case goes for the other So I'll just copy this and go over here and paste it right there. And remember, this is positive integer, so we're assuming that the user is not going to input a negative, so a negative won't work either. So this is the factorial. This is how it's going to work. And now that I'm using for loop, now I'm going to use this with while loop. So let's have the test of here. So the invocation, so console output, we'll say using for, I would say factorial using while, and let's put inside for. Now I'm supposed to get 120 as the answer, so let me just double check it, get this play button, and yeah, 24 as the answer, because factorial of 4 is 24. If I said 120, please ignore that. That was the answer for the factorial of 5. All right, so 124 was the answer. Now let's create our recursive function, the real function that we came up for. So by comparing it, now you can see that they're similar to the prototype is similar. Int, we're gonna say factorial using, let me change that up, recursion. So there you go. And inside of it, I'm just gonna put a number, just what we want. And now, before having a recursive call, remember, you would have to define your base case. So my base case is that if the number is less than, I would say over here, which is less than 1. So if the number is less than 1, what's going to happen is that basically I want it to return the tot. All right. Now what's happening over here is that I have to return the total. Now where do I define it? If I define over here like total is equal to 1, now every time it's going to loop through it, it's just going to be total 1, so it's not going to change. So where do I add this is basically inside of my arguments. So in my input parameters, I would create another one which is going to be total, and then basically I would have a default value of 1. So now that it would work, so basically in the other case over here, it's basically going to have total is equal to total multiplied by number. It's just going to multiply it with a number, and over here we're going to recall this, so factorial using recursion, and inside of it we're going to pass in num minus 1, because now we are decrementing the number which the user is going to input. Like for instance, it's going to be 5, it's going to go to 4, it's going to go to 3, 2, and 1, and the total is just going to be same over here. So we're just going to put the total, whatever the computation is result over here, would put over here, would just pass inside. So this is the recursive model of this. So let me just have this implemented console output, and I would say factorial using recursion. And inside the recursion, I would put, let's say, factorial of 3. Now this thing is supposed to be providing me 6. So let me just put this as comments, and now let's run the code. Run code, and I'm supposed to get 6 as my output. And I get a 6, and I also get a warning control reaches end of non-void. All right, so that warning is just asking me to change a bit over here. But one thing I wanted to address is that you don't necessarily have to explicitly define it here. This could be also reduced to another thing over here. We could just say total multiplied by number, and this is the same thing too. Whatever the number you're getting, you're multiplying with the total, and that's what you're calling inside again and again. So let's have a visualization of how this recursion function is properly executed. So what happens is that first time, let's say I called into 3. So I call it with factorial using recursion, and I called it with the number 3, and the total was in the default location was 1. So this thing approached, and what it checked over here was the number less than 1. It wasn't, it was greater. So what it did is that it ignored the return total, and it's called factorial using recursion, but now it changed it. So it would say factorial using recursion, and now it would be 2, and the total would be basically the number which was 3 multiplied by total which was previously known as 1. So it would be 3 over here. So next, after this step, what we're going to do is basically go again, and it's going to be decremented to 2. So it's going to check over here, no, so it's going to call this function again. So it's a factorial using recursion, and now this case it would be 1, and then the total would be now equal to, now you could guess it, that it was 3, which was the previous, number, and then the number which was num, now it's 2, so it's going to be 3 multiplied by 2, and that is equal to 6. So that is going to be in our total. Then we call it again factorial using recursion, and then now we call it with 0, and we have a total of 6 multiplied by 1, because the number that was assigned over here was num, so total was 6 and then the number was 1, so it gave us a 6 result. Now we'll check it over here. If number is less than, so the number which is 0 is less than 1, this is correct, so it returned the total. So it returned the total over here, and the case for that was, let's check what the value was. So the value was 6, so it's going to be returned over here. Now when we go back to our last most recent call, and you would see that this was returned by this, so its successor would be controlling it, and then it would be just calling the return 6, because that's the last expression. After that there's just a return, and that this function is calling this, so this is returning 6, and I hope this makes sense because it's just returning 6 over here. And then after that we have return 6 on the other case when we're calling this one, and then the last one will also return 6. So this is our recursive stack, and this is how it's implemented, and this is how it's basically visualized in the back end. So I hope you guys got it clear. I hope you guys got a thorough picture of how it works. I hope you enjoyed this video. I hope you got more insight of how recursions work. If you like this video, please subscribe to the channel, and also stay tuned for more videos. Thank you. Peace out.